Hello and welcome to another episode of Magic Made Science, and you join us on another beautiful day here at the Magic Made Science Tester Track Stadium. As you can see, we have the honour of working with this beautiful machine, the LEGO Mindstorm Tracker. Did you say we were at the Magic Made Science Tester Track Arena?
That's right, my super-brained colleague.
Right, 'cause it looks like we're just in a hut. In a car park.
Anyway, ladies and gentlemen, boys and girls, I'm now going to hand over to our technical advisor as I move, who is going to show you how to get this beautiful machine going. As I move...
Greetings, unlicensed humans. Today we are going to teach you how to drive your Eve robot, since you guys think he is so great and all. If you recall from the last episode, I explained to you what a motor is and how it is used to create motion in a robot's arms. Now we will show you how to use motors for turning wheels and creating movement in your robot. You will notice on your Everstorm's P brick that he has 4 sockets labeled A, B, C, and D. These are the outputs, meaning that power comes from them. Each one can be connected to a different motor.
So for this experiment, we are going to connect motor B to Eve's left side wheels and motor C to Eve's right side wheels. If this is not already the case, please adjust your robots. Now, make sure you have a good amount of room when placing down your Everstorm robot to begin this experiment. You don't want your robot running off of a table or into a wall or oncoming road traffic.
The first thing we are going to learn is how to make Eve move forward and how to calculate the distance we want Eve to go.
Now, before we make Eve go, we must understand how to tell him how far he is to travel. Remember, he is still quite unintelligent and we can't simply point out a spot for him to travel to.
And so we must take control of Eve using the unstoppable, unavoidable, almighty power of maths.
To begin, we must do an experiment. We know that Eve moves on wheels. If these wheels were to turn one full rotation, turning until the wheel's position returns to how it was before it began moving, the robot will travel a certain distance by the time the rotation is complete. First, we must find out what that distance would be. This can be calculated using a program and a ruler.
First, align the 0 point of the centimeter side on your ruler with the center of your Everstorm's wheel. This will tell you how far the robot has traveled.
You must next open a new program on the EV3 software, as we are now going to create the program that will make Eve's wheels perform one full rotation. I'm going to call this program Roll. Once you have a blank program open, you must begin by adding a steering block, which is this block here. This block controls 2 separate motors at once, as you can see in the top right hand corner of the block. This block controls motors B and C. First, let us go to the options here and change the speed to 50%. This means Eve will move at 50% speed. Next, go to this button, the rotation option, and select the option 1. This means Eve's wheels will perform 1 rotation. This completes your program. You may now connect your Everstorm to your computer and select here the download option before going to your P brick to select your program. Again, be careful to make sure Eve has room to move. Looks like forwards is backwards for the tracker. That's alright, I needed to show you how to make your robot go backwards anyway. Simply change the power or rotation options to negative numbers on the steering block in your program. This will mean the same amount of power will be put into the motors except in reverse. Once this is done, you can then run the program again.
Congratulations on your first time moving, Eve. These are the baby steps of a much greater adventure. So you should have found that Eve has moved about 9.5 centimeters. Now, using mathematics, we can understand why Eve has moved this far. First, let me introduce you to pi. This is pi. Say hi to pi.
Hi, Pi!
Pi is a mathematical symbol that has been used for over 2,000 years to calculate the size of circles, like the circle shape of Eve's wheels. You can't measure a circle size by its radius, the distance between the center of a circle and the edge of it, or by its circumference, the length of the outside layer of the circle. But how does one measure a curved surface like this one? It cannot be done with a ruler. It could be measured with a piece of string, but Victor cannot afford to buy string.
I spent the money on time travel.
This is where pi comes in. The symbol is of Greek origin and represents about 3.14. However, that is just the number calculated to 2 decimal places. The number is actually much longer than that. Here is what it looks like calculated to the 10,000th point.
For this reason, it is best to do mathematics involving our complex friend pi using a calculator.
So here is how we use pi to calculate the size of a circle.
This may look like a complex formula, but once you learn this set of numbers, you'll find that it's very easy to remember because it's so short. And you do not even realize it yet, but you already know the meaning of all of these symbols. The C in the equation stands for circumference, the word as I moved defined earlier, meaning the length of the outside line of a circle. R stands for radius, meaning the distance between the center of a circle and its outer edge. And pi you've met. So the equation is actually quite simple. It shows that we can work out the length of the outside line of a circle, also known as its circumference, by doing 2 times the radius times pi. Now let's apply this here. We know that the radius of Eve's wheels is approximately 1.5 centimeters. Thus, let us place this number in the place of the radius in our equation. Here we see our result is 9.42, just as you measured it when Eve's wheels did a full rotation.
Thus, we know that you can work out the size of a circle using maths.
So much more thrilling than actually speeding around.
So remember that formula, children. Circumference equals 2r pi, and remember r is for radius. This will give you ultimate power in the world over that most puzzling of things, circles.
This is true. Imagine if you wanted your Everstorm to move 19 centimeters. If one rotation moves Eve 9.5 centimeters, then how many rotations would be required to make him move 19 centimeters? 2. Easy, and this can be applied to anything.
Say you wanted Eve to travel to the market to get some food for you. Let's say it would take 10 rotations to get to the market, because you have a very good, conveniently placed market. We would then know that this means the market is 94 centimetres away, because 10 times 9.42 is 94.2.
So we can easily do 19 centimetres because 2 times 9.5 is 19. But what if we wanted to do, say, 25 centimetres? This seems more complex, but it's actually quite simple. All we need to do is work out how many times Eve's wheels would rotate before we reached 25 centimetres. In other words, how many times can we count to 9.42 before we get to 25? Oh dear, always the weak who go first. Don't worry kids, it's really not as complicated as it sounds. And remember, if you ever need anything explained to you again, you can always use your own time machines to rewind the video and go back and rewatch any bits you may have missed before. So, now, how many rotations do we need to get to 25?
This can be worked out by dividing our desired distance of 25 centimetres by the length of one rotation, 9.42.
2.65.
Thus, we now know that if we enter 2.65 into the rotation option on Eve's steering block, this will result in Eve moving 25 centimetres.
Congratulations, you have cracked the circle's code.
Excellent.
Where are we?
Wake up, Ulu. You're sleeping through important and awesome stuff right now. Whoa. Section over. Think you've got everything memorized? Get on that learning material. See you in a sec.